Recording. We are recording. Okay, Dave, I'm going to turn it over to you.
Terrific. Thanks, Darcy. Good morning, everybody. It's good to sort of virtually see you all. See a lot of familiar names for participants today. I'm glad to be here with you. Glad we could do this virtually too. It's really crazy how everything has become virtual. I went to a Zoom wedding the other day. It was crazy. My niece got married, and we planned on a big family trip to West Virginia for the wedding, and that didn't happen. And then all of a sudden there's a Zoom link. So we're all participating virtually in so many things now. But we're making this work. What I want to talk to you about today, I've got about 25 minutes. I want to talk to you about QuickCapture, more recent mobile collection technology from Esri. It's becoming very popular for a lot of reasons. Let me just kind of first switch off my, stop sharing my desktop. Well, actually, I guess, so full disclaimer, I'm having challenges with my screen mirroring technology this morning. So when I show you my phone, instead of being like really sophisticated like most people are and showing it on the video, showing it on the desktop, I'm gonna have to show it to you like this. So I apologize for sort of the hokey experience, but that's what I'm dealing with today. So QuickCapture is a mobile application. There's two components to it, which we'll talk about today. There's the mobile piece that runs, the app piece that runs on your device. Like this is my iPhone 6. I think part of the problem is my phone is so old. But there's also a tool that allows you to build, a web-based tool that allows you to build your QuickCapture projects. But this is, the idea behind this is to have the simplest possible interface for collecting data in the field. You know, we started off with Collector, which is an incredible tool that I know many of you use, but definitely requires some training and some understanding to be familiar with it. QuickCapture is one of those things you can just kind of put it in someone's hand and they can figure it out. So it allows you to collect points, lines, and polygons, and it's really got kind of a big button design. So this is like a marine sampling, marine pollution sampling thing where I can collect information like along a beach saying I found bottle caps and straws and plastic bags and whatever it may be. So I could type in the number of items I found there and then just populate that. And all of a sudden I've collected a new straw on the beach. Can also record linear features. At the top, you see that record transect lines. So you can actually use this to collect and walk a route, and it will collect that route line for you. And while it's blinking, it's collecting, and now it's not collecting. So it's a really simple interface. Also, one other little tip on the bottom is we can take photos, of course. So you can take photos of the data we're capturing. But the idea behind this application is it's just a big button, simple to use app. So I want to have a couple little components of our presentation today, kind of give you some example of the use cases and some vision of how you can utilize it and how I'm seeing people use it. I never really told you what I do, but I'm a solution engineer and I support our users in the state of Colorado, our local government users in the state of Colorado. So I'm working with a lot of folks in local government who are interested in collecting data, interested in having sort of an easier approach to collecting field information, maybe data about trails, or maybe data about pollution or graffiti or other incidents like that. So we're seeing a lot of traction in this. So I'll give you some of my experiences and use cases from local government. And then I'll also just kind of give you a little overview of how to build your applications. So again, as I've said several times, it's a big button. It's sort of a very simple to use application. The key thing here is you can put it in someone's hands and they can use it with little or no training. The idea is no training. And this complements our other applications. They all have, our other mobile applications, they all have specific kind of use cases. QuickCapture's really got its own use cases being the simplest way. We can also use it at speed. So I've made a few projects where I'm like identifying certain vehicles just for fun, like certain types of cars. So I have a QuickCapture app on my phone, and while I'm riding my bike around my neighborhood or driving, I can just collect, and take a picture if I want. So you can do things while you're moving. It captures the location when you push the button. Some common use cases, like we're seeing a lot of interest in things like snow plows. This is an incredible example where you can track sort of the, not sort of, but track the progress of snow operations, snow removal operations, capture information about signposts and guardrails while you're driving along a highway. So we're seeing a lot of things happen in DOTs and also in aerial surveys. I haven't myself seen these yet, but this is, I think this is going to be an area where there's a lot of popularity, especially in the utilities industry and forestry and whatnot. So on the right, that iPad picture is like what it might look like in another piece of Esri tech, you know, just with all the different types of features to collect. But on the left, that example behind it is a quick capture project where you could just very quickly select the feature you're trying to populate, whether it's some damage or whatever it may be. Very quickly able to do that. I work with a lot of emergency management departments and in the state, and there's been a lot of traction in sort of this mobile project paradigm. I shouldn't say there's a lot of traction. There's been a lot of activity in this very common mobile paradigm of collecting data and presenting it in real time on a dashboard. We see this over and over and over again, whether it's about coronavirus or whether it's about crimes, weather, traffic incidents like Waze data, for example, or real-time data coming through like a geo event server. There's this real common thirst for the ability to see stuff in real time in a dashboard and collect it in real time using a mobile device. Emergency response is no stranger to this. Here we have a couple of screenshots of a couple of emergency response applications. One of them on the left is just sort of an incident reporter. Whether you have, for example, move my mouse over here, whether you have emergency or non-emergency police assistance. And you'll see how these things are kind of grouped intuitively into little panels. I'll show you how we can do that too. But so we have like police, fire, EMS, and so on and so forth. On the right example, we have an urban search and rescue, which I know is common. We do a lot. People do a lot of dashboard surveillance after incidents, and this is a wonderful tool to use. And one of the things I like about this is you can also set up, have your project set up so that users need to specify something like a team or a transect or something. So everything that they collect is going to be appended with some information about like the team or the transect or the project that they're particularly working on. I'll show you this in a minute. Here's an example from Quebec, which is a trail maintenance application. And this is really interesting where we have on the right, or sorry, only move down here to the bottom, on the vehicle, or sorry, on the bike rider. Sorry, neighbors cutting the yard. Hopefully that's not too loud. But they have, in this case, the cyclist has a device mounted right here on their handlebars, and it's an iPhone, and this is what the iPhone shows. So as they're riding, and they also have an external GNSS receiver right here. This is going to give them better accuracy and higher fidelity, more pulses back, basically, more information about the location, more frequent information about the location. But in this scenario, the cyclist is riding around and collecting little sign posts or intersection posts. They can also add photos if they like of things that they see. But this is really cool. I love this down here. As they're riding along, they can specify the trout as being like a beginner, intermediate, or difficult trail. So they push the button, they're collecting the trail the whole time as they're going along, right? They're collecting the trail, and for this particular segment, it's intermediate, and then they switch the button to beginner, and then switch to advanced, or however they're gonna do that. But they can do that in real time and be collecting the data in real time. And on the back end, you see the map of this mountain bike course that they're collecting the data for. So let me kind of show you or talk about the components of the application and how you're going to be working with it. There's the mobile app itself. We've got it available for iOS, Android, and Windows. It supports ArcGIS Online and ArcGIS Enterprise 10.7.1 and newer. Can work online and offline as well. Now, as far as the licensing goes, this may be not familiar to everybody, but our user licensing and ArcGIS and our platform comes along these different 5 categories: the viewer, the editor, the field worker, the creator, and the GIS professional. And you all are typically going to be GIS professionals. You've got Arc Desktop and you've got complete access to the whole platform. But as far as what QuickCapture comes with is, if you have field worker users, these are people that are allowed to edit, and they also get the field apps bundle. So they can use Survey 123, Collector, QuickCapture, all these applications. That's included with that type of user. If you are an editor, so in order to use QuickCapture, you've got to be able to edit data, right? So you got to be an editor of some sort. So if you're an editor, you can add on the license for the application, but it's included with the field worker, the creator, and the GIS professional. So I think many of you who have who are GIS users already have this license. And the way we work with this inside of ArcGIS, whether we're working inside of ArcGIS Online or Enterprise, is through this tool called the QuickCapture Designer. And this is kind of a sped up video of what that interface looks like. I'll actually just show it to you here. I'll just show it to you right now. So let me give you a little demonstration. And kind of move some real estate around. Hopefully you all can see that screen still. Couple things is I'm going to build a simple project based on the data in this map, and this is just a ArcGIS web map showing feature layers in it. The feature layers are bike trails that are paved, not paved, and points of interest. And you can see the legend. We've already built the legend for those features in here. So this is kind of what we're dealing with, and this is where I am locally now. So I'm going to create some routes in my corner of my house here in Boulder. At any rate, so when you're creating a QuickCapture project, you can start from a variety of different things. And let me just kind of show you what you can start from. I'm going to go here and create a new project. I can start from existing layers that I have, which I'm going to do, but I can also start from a template. And if you choose a template, we have a variety of starting points, just like we do with solutions and other applications. We have a variety of frameworks that you can start with, and either keep it straight up the way it is, like the marine debris sampling. That's the template I showed you earlier. It's got all the supporting feature services and feature layers and icons and symbology and cartography included with it. Or you could build your own. So let's go back, and I'm going to go ahead and create a new project, and I'm going to start from an existing set of layers. So now it's looking in my organization, and there's a whole bunch of stuff in here. I don't even know what half of this stuff is, but I'm going to start from this bike trails layer right here. So I can go ahead and click on it, and I'm now building a project. The way you work with QuickCapture is you build a project. The project has the layers you want to edit. It has all the look and feel of the application, all the ancillary information and icons and whatnot, and map to go with it. So I'm going to go ahead and create a project. And it has this cool little button here that says create buttons from layer symbology. Just going to make it a little bit more easy. There we go. Give it a name, and I'm going to create this project. So right now it's setting up kind of all the stuff in the back end, and it looked at the feature layer that I had. Okay, so let's go back and just look at it real quick. This is it. So it's got bike trails, POI, trails paved, and trails not paved. And it's got these 4 colors, these 3 colors, and those 3 colors. So as soon as I go in, since I chose to have it use the existing colors, I get them kind of built into my application. And at the bottom, this is what my QuickCapture project or app is going to look like. I can preview it in using different types of devices, different types of iPads and whatnot. So I'm going to go back to my iPhone, and I'll put it on an iPhone here so we can work with it. The first thing you notice is that it's organized, which I really like. These are organized based on the sublayer. So there's a POI, a trails paved and not paved. So these are all grouped or organized. I can add more groups in here if I want. I can also add more buttons in here if I want to different groups. Okay, so, but the important thing here is to note that it's looking at your feature layer, it's looking at the structure of your feature layer and just kind of putting it all in here. Now at a high level, I can do things like select the group over here and do things like control the number of columns that I have. So we'll go ahead and make it 4 columns. You know, maybe that's good, maybe that's not good. We'll make it 1 column. You know, so just however you feel like it may be easier for the user to collect the data, you can really have a lot of control over the layout. You can also have the default state where it's collapsed. So if it's data that's not commonly collected, you could have that set up to be collapsed. So this is stuff about the actual group. Now let's look at the buttons. Let's make this 2 columns again, just to make it a little better looking. So now that we've selected a group and worked with the group, we can collect individual or look at the individual buttons and what they do. So we have all these appearance capabilities, which are nice, but the important thing that I want you to know about is the data on the back end. We can actually look at and specify our target feature layer. Like I've got my points of interest target feature layer. I can specify if the user is going to be able to collect single points or streaming points, if they want to be able to take a photo or not. And if they want to take a photo, is it required of them? And do you want to hide the camera preview? Like maybe you just want to take a photo with wherever the lens is pointed at that particular time. You don't want to open up the whole camera device, the whole interface with the viewfinder and click the buttons. You can hide that if you like. Notice that as soon as I chose that, it has a little picture icon on it. So we can have photos enabled as well. Also, there's something else that many devices have a lot of data that's being collected. I think in some cases up to like 40 variables that are of data that's being collected. You can access all those fields in here. So, for example, when you're specifying, if you want to be able to specify something from like user input, we can do that, but we can also grab device variables. And these are the device variables. For example, like the speed, the vertical speed, the lat, the long, the altitude, all these 40-some variables can be captured in here as well. Each of these buttons, we can control as I mentioned, I'm not gonna won't spend any more real time with that, but we control the size and the shape and the layout and kind of all that kind of stuff. And we can add images to them, make them look really nice. At the application tier, we can control settings as well, such as the location accuracy and display preferences. We can choose a different background color if we like. We can set a required accuracy. One of the things I like is the ability to actually allow location edits. So if you place something, you may want to actually adjust it a little bit. Maybe the GPS accuracy is only 30 meters on your device where you are at that point. You maybe want to move the point a little bit. You can do that as well. So there's a variety of variables we can access through the actual interface itself. And then once we've done this, we can go ahead and save it. And I'm going to go ahead and scan my QR code now. And I'm going to open up this app in QuickCapture. Do that again. And inadvertently push the button. Okay, and come on. There we go. It's a new project. Sorry, I know it's very exciting seeing the back of my phone, but I'm actually just opening it up. So you scan the QR code, and then you have your project up, project available. Mine's opening right now, and Come on, phone. All right, so while that's happening, the application is opening up. QuickCapture is opening up with my project in it, and I'll be able to view this immediately. And I see that, if I see that when I'm looking at this, I want to change kind of the look and feel of it, or change the orientation, or change some features, I can do that right here and make those changes for the user, and they can see those right away. Couple more items I definitely want to show you. And I apologize for my screen mirroring not working. It's really kind of hokey. Is just a couple more background things I want to make sure. The device variables, there's over 40 of them. These can be captured as well. I just kind of showed that very briefly. I mentioned I really like the ability, especially in emergency management stuff, to be able to capture information about user inputs. So like if you're going to be doing a survey and you maybe have a crew that you need to append crew information to all your features, you can do that. So you can collect or append that data to your project as well. And the one thing that's also interesting about this is that you can do nested data capture. This is actually allows you to report and capture multiple things at the same time, like the bike scenario we looked at earlier. Forgive me. So we're collecting a bike path the whole time, and we maybe want to also capture, we're streaming the route, the path. We may also want to capture an intersection or a traffic light or some other information. We can capture multiple features at the same time. And one of the things I do want to mention is the external GNSS receivers will add a lot more capabilities as far as like higher frequency data collection. I think most devices could give you, most devices like a smartphone could give you a location like every second. Some of these external devices are much more sophisticated and give you much more higher accuracy data, higher frequency data collection, like multiple times a second, for example. Couple more things, and I'll open it up here. Is we do support ArcGIS Enterprise 10.7 and above. The designer application is not in there until you get to 10.8. And there are a variety of really, really great blog posts on QuickCapture written by the team. Ishmael, I think many of you know him. But those are some of, there's a lot of really great resources on that. As far as getting started with QuickCapture, there's one thing I want to show you. If you go to Learn ArcGIS, Learn ArcGIS, and let's search. I like to go to the lesson gallery over here, and I'm just going to search on a technology. I'm going to go QuickCapture, and there's a few different things, resources in here you can start working on today. There's a learning path on working with QuickCapture. It has things like lessons and videos and stuff just to kind of give you an overview on it. But if you want to actually just get down and start working with the tech, then I would use this one of these lessons. These are actually the same: find, inspect, and replace guardrail in ArcGIS. And this is with ArcGIS Enterprise, and one's with ArcGIS Online. But these are great ways to get your hands on the technology and have like an actual thing you're trying to solve. So I apologize for sort of the hasty demos and the lack of screen mirroring technology, but I think I have a few minutes. Darcy, can we open it up to questions?
Sure. If folks want to, do you want them to ask questions, Dave?
Yeah, sure. Go ahead and ask questions.
Okay. If you have a question, just raise your hand. In your, there should be a little hand option to raise your hand. I am not seeing any hand raised.
I see one thing in the Q&A. Thanks, Dave. Looks really cool. Thanks, Heather. Yeah, I'd love to show you this in more detail and give you some more use cases, but that was just the whole point, was just to give you a little little teaser there, a little taster to let you know what you have access to. So looks like we're good on questions. So I'll be respectful and stop talking now. Thanks for your time.
Thank you. Perfect timing. We are just hitting the half hour. So. Okay, so next we have Adam. Adam, do you want to share your screen and your video?
Yep, working on that right now.
And then don't forget to introduce yourself.
Sure. Hang on, having some issues here with my Zoom. How's that?
Yep, you can see
Okay.
it.
Cool. Yeah, I'm Adam Carnow. I'm with Esri. I'm actually out of Charlotte, North Carolina. I'm a community evangelist. Hopefully, we've connected on either LinkedIn or Twitter or sometime or not. If not, I would love to connect with you. So be sure to follow up with me. I'm going to talk to you today about the path from GIS Manager to GIS Leader. So what I do as an evangelist is I focus on the business side of GIS, not really talking any technology at all. And I help people move up in the organization. I help managers do more and become leaders. So I hope you'll learn a lot with this presentation today. And I got a lot to get through, so I'm going to just hit it hard. And I will provide a copy of the slides, and they are hyperlinked to the resources that I'll show. So you'll be able to access the websites, et cetera. And there's also a version of this presentation already available as a video, as well as a set of 3 blog posts that I'll share as well. Okay, so the reason why we need to become leaders in GIS is because people don't have a good appreciation for the value of GIS. So here's a quote from an article 9 years ago that said, generally people outside of GIS think of GIS just as maps or graphic product or the younger brother of CAD. And that was true 9 years ago, and unfortunately that's still true a lot today. Here's another article 5 years ago, GIS is often seen as maps or visual graphics product, and the more advanced capabilities are ignored because they remain unknown to key departments and decision makers. And then here's one from 2 years ago. As expected, lack of awareness among users and policymakers remains the biggest challenge for the industry, with over 38% of the CIOs surveyed listing it as the primary hurdle to getting the most out of their GIS investment. So we have an image problem and we need to change that. And the way we can do that is by not talking about technology. We need to talk about capabilities, because leaders and managers and executives in your organization are very interested in adding new capabilities to the organization and to the staff. They're usually not so much interested in the details or in the technology. So a capability is the power or ability to do something. So let's shift from talking about GIS and let's talk about the capability that GIS can enable in an organization. And that capability is best known as, I think, location intelligence. And one of the links you'll get is to this video. It's about 2 minutes long that Esri put together with Fast Company, and it's intended to be directed at executives, and it tells them what location intelligence is in very plain language. And it actually shares a lot of statistics that many executives already know what location intelligence are, and they're willing to invest time and resources and money into it, and they're on board with it. So that's a great thing, and that's another reason why it's really good to start talking about location intelligence. And then last year, Esri Canada put out this amazing report. So I heartily suggest everybody download this and read it. And it's called Winning with Location Intelligence, the Essential Practices. And they surveyed 200 organizations across Canada in all industries. These organizations had 500 or more employees. And they were able to distill which organizations were doing the best, being the most successful with location intelligence. And then they were able to extract why they were successful. So they got real world best practices proven out there in the industries. And then what they were able to do was distill these best practices into these 5 categories, which what they call the 5 pillars of location intelligence, which are strategy, organization, technology and data, culture, and literacy. And this is really great. So what this shows us is if you want to be successful implementing or enabling a new capability like location intelligence via GIS, that you can't spend 100% of your time on technology and data. You have got to spend your time across all 5 of these buckets. And there's a difference between implementing technology and enabling a capability. So if you're going to enable the location intelligent capability and deliver value to your organization, you've got to work on these 5 things. And so I want you to look at these numbers. These are important numbers. You know, as I move through the presentation, I'm going to reveal their meaning, and I want you to think about it each time. Now, these numbers are the results of a survey that I've been doing over the last 2 years by surveying GIS people across the entire United States, over 700 people. So let's look at the 5 pillars of location intelligence, and let's start with the first one, which is strategy. So if you're going to be successful with GIS in your organization, you got to have a strategy. And the importance of a strategy cannot be understated. In fact, in a September 2019 survey from McKinsey & Company on how leaders in data and analytics have pulled ahead, they found that the creation of a strategy now ranks as the #1 challenge to, and the reason for, a company's success with data and analytics. So the organizations that are most successful with data and analytics, the reason they are is their strategy. The biggest challenge to realizing the true value of data and analytics is not having a strategy. So I can't make it more important that you've got to have a strategy. And a lot of you might think, well, if I'm going to put together a geospatial or GIS strategic plan together, I might get kickback from my executives on why I'm doing that and why I'm spending time and money on it. Well, great article here from Matt Lewin from Esri Canada, available on LinkedIn, talks to you about how to justify your geospatial strategy with an executive. So he lists these 5 things. You're going to unlock new sources of value. You're going to strengthen your overall digital strategy. You're going to enrich the customer experience. You're going to establish a shared data foundation, and because your IT strategy probably missed it. So here's my first number, and that is that 64% of organizations that use GIS do not have and maintain a GIS strategic plan. And that is a problem. So the majority of us that are out there don't have a plan, and yet it's the most important thing to have to be successful. So let's talk about what is a geospatial strategy. Well, geospatial strategy is a business-oriented plan that defines how an organization will use GIS to achieve its goals. The key word is business. This is not about technology and standards and what do we name our layers and what projection they're going to be. No, this is focused on the business. So an effective geospatial strategy connects your business needs with the right people, processes, and technology to help you overcome challenges and improve results. So the #1 reason you're putting the strategy together is because we're going to help the organization overcome some challenges and improve their results through the use of this technology. Now, best way to put this in simple terms is to look at these 4 circles. So the objective is to first focus your work on assisting the business. You do this by first identifying what the business goals are for your organization. Now, these should be easily accessible and documented in plans, in initiatives, in objectives, etc. Whatever the people at the top are working on and think is important, that's what these goals are. So in order to reach your goal, you've got to overcome challenges. So the next thing you do is you identify what the challenges are that the organization is facing that's keeping them from achieving their goals. Talk to the people that are who are in charge of meeting those goals. Ask them what their challenges are. Then once you learn their challenges, you can then propose some business-driven GIS solutions. This GIS solution will help you overcome this challenge and therefore meet your goal. If you do that, you will create the business value of GIS, and therefore you've gone from being a GIS manager to being a GIS leader. And that's what that strategic plan is all about. It's about focusing your work on helping the organization meet its goals. Now, let's talk about what can happen if you do show the business value of GIS. I want to talk to you about a new success story that just came out last week that we just published from Bonneville County, Idaho. This is in the southeast part of Idaho. The county seat is Idaho Falls. Population of the whole county is about 115,000. Now, they started with one GIS professional in 2015. Now, because they're susceptible to wildfires, they deployed some configurable off-the-shelf ArcGIS solutions to support wildfire response. And this completely replaced paper-based workflows that they had always used in the past. Well, then, unfortunately, sure enough, they got hit with some wildfires. Now, as a result of this, the county provided a better emergency response experience to the end users than they ever had in the past. Now, this, along with other great business value work they did, convinced management to let the county add 5 more full-time GIS professionals. Now, we all know one of the biggest challenges is getting approval for more full-time GIS staff. Here's an organization that's not that big, 115,000 in population, and they were able to show the value of GIS in a very dire situation like a wildfire, and sure enough, they were paid back by getting approval to hire 5 more professionals. So this is what can happen if you focus your work on providing real business value and overcoming challenges. So Esri has a method that we've put together, a model, a template, if you will, for creating a geospatial strategy. And it exists, it is part of these 4 pieces. Number 1, you understand your organization, so you understand those goals and challenges. Number 2, you plan the response to that. How are we going to help those challenges? What technology do we need? What people do we need? What processes do we need? What training do we need? Once we've got that together, we actually act. We implement the actual solution. We then review that solution to see how it did and keep it running, et cetera, and migrate it, et cetera. Then the goals and the challenges that the organization are dealing with are always changing. For instance, the COVID pandemic came out of nowhere. So we must revisit that understanding. So we go back and we understand the new goals and the new challenges. We then plan and act, et cetera. So this is a cycle that goes on. And the idea here is that you're trying to maximize the impact that you have in your organization. So we've put together a document. You can download it here. It's a short document at this URL called The Approach to Maximizing Impact. And this document will get you started on understanding a geospatial strategy and how to create one on your own. If you want more help on this, just reach out to your Esri account team. All right, so let's look at the second bucket or second pillar here of location intelligence, and that's organization. There's lots of different things available or comprised about organization. I'm going to focus on organizational governance, and I'll go back to my second of my 5 numbers, and that is that 76% of organizations that use GIS do not have formal governance in place. And this is, again, another huge challenge as to why you're not providing the ultimate value to your organization. So I heartily suggest you start to work on some formal governance if you're part of that 76%. And some of the resources that I'll steer you towards is Matt Lewin of Esri Canada. He is a prolific writer and speaker and someone that leads thought in this area of GIS governance. And so if you check out his blogs and articles on the Esri Canada website, there's also a video of a presentation he did at a UC a couple of years ago on governance. You can learn more about it and then start to understand how you can put your own governance together. All right, so the next of the buckets is technology and data. And here's the one that we're most comfortable with and we probably spend most of our time in. But part of being successful with technology and data is following best practices. And Esri has a document that outlines all our best practices called Architecting the ArcGIS Platform, Best Practices. And sure enough, I polled everybody and 78% of them have not read it. So if you're not familiar with this document, you can download it here at this URL. And this document is kept up to date. It is updated at least 3 times a year. So you want to make sure you get the latest version of it and that you constantly check on when the new one is. And this one will, This one will lay out all of the main best practices we have in technology. Many of these we've borrowed from the IT world. They're not specific to GIS or ArcGIS. And they deal with people, data, process, and technology. So know this document, read it, implement it. Again, talk to your Esri account team about how to implement these best practices. They're called best practices for a reason. If you implement them, your system will run better. It will run smoother. You'll have fewer tech support calls, I promise you. It'll really make you sleep a lot easier. Okay, now let's talk about the fourth pillar of location intelligence, and that is culture. Again, culture is a wide area. Let's focus in on one part of that, and what I would like to focus on is change management. You can create the best data and the best application in the world, but if your organization doesn't see value in it or doesn't want to use it, then it's not delivering value. So there's one thing we've got to work on is change management, and I'm talking about organizational change management, not software change management. So sure enough, my next number is for my survey is that 84% of organizations that use GIS do not have and maintain a change management plan. So if you've got a change management group in your organization, go talk to them and tell them that you want to get involved and implement change management in your GIS. If they don't, then start to identify some ways to learn more about change management on your own. So again, the biggest challenge of a successful GIS implementation is the people, and we deal with the people with change management. So the solution to that is implementing a change management program. And this definition of change management comes to us from ProSci, which is one of the leaders in change management, and that is the discipline that guides how we prepare, equip, and support individuals to successfully adopt change in order to drive organizational success and outcomes. And research has shown that organizations that implement change management programs, they experience 6 times more of their successful technology adoption than those that don't. So it's really critical that if you're going to successfully adopt technology like GIS, that you use change management techniques. And sure enough, Esri is so invested in how important this is that we have a change management consulting practice. So if you want to learn more from us about it, reach out again to your Esri account team and we can connect you with them. And one of the members of that team is Michael Green, and he's published quite a lot of articles, and he also has a video presentation on change management as well. So again, you'll have access to all of these links when I deliver the slides. Okay, and some of the things about culture change is that there's focus areas. You need to have effective sponsorship, continuous communication, proactive resistance management, so dealing with the people that are resistant to change, workforce development and training. And remember that over 50% of the sponsors do not understand that they're sponsors and their role and what that means. And sponsors are just as likely to create resistance to change as employees. So you've got to make sure to not just work on the users, but make sure your sponsors, the people that support your GIS, are on top of the change management as well. Okay. Oh, and it is the #1 factor for successful change is an active and visible sponsor. All right, so let's get to the last pillar, which is literacy. And again, back to one of my numbers, 84% of organizations that use GIS do not have and maintain a workforce development plan. So please reach out to your Esri account team. We'll get you in touch with an educational consultant who can help you create a plan at no cost. And we have a whole bunch of learning plans available on our website as well that you can use. All right, so let's wrap this up. So part of being a leader is getting people to understand the value. And I think that a lot of people hear GIS and think map makers. So I've seen a lot of people change their job titles to get rid of that stigma. Map making is a very valuable skill, but we can do so much more than that. So here's some real world examples of people that have changed their job titles out there across the country, as well up in Canada and Australia as well. And then what my vision here is that, you know, every organization has some sort of CEO, and over the years, as technology has gotten more complex and delivering more value, they are expanding the number of executives that deal with technology. So quite often organizations will have a CTO and a chief innovation officer and a chief data officer and a chief analytics officer. Well, why shouldn't we have a chief geospatial officer? If we're delivering enough value, we can get executives to create that position, and then there's a great place for us to move up into and do a lot of help in our organization. And here's a whole list of examples of GIS managers that have moved up, again, across the globe. We've got CIOs and CTOs and CDOs and all kinds of innovation officers, et cetera. So a lot of your peers are doing this, and they're moving up in the organization. I'd like to highlight a few more of them. This is Todd Shanley, who works at Cabarrus County, right up the road from me here, outside of Charlotte. And he is a CIO, and he started out as a GIS intern there. And he recently won an award as one of the top 25 doers, dreamers, and drivers of 2020. This is Nick O'Day. He's the Chief Data Officer at Johns Creek, Georgia. He used to be the GIS manager there. And Tracy McKee used to be the GIS manager, and she's the now Chief Innovation Officer at Charleston, South Carolina. Now, there are some people that are reporting directly to executives that don't have the title. So don't worry about the title. But if you can at least report directly to an executive, that shows that they value you and your work, that they want to control you and your work directly. So these are 4 examples of people that are already doing that. So definitely keep these 5 pillars in mind and work on all 5 and execute using some of the resources I talked about. And then get help. Nobody can do this alone. So us, Esri, and our partners are here. You've got your account team. We've got a whole slew of subject matter experts. We've got great people in our services group, whether it's training, consulting, or technical support. Great partners that are earning all kinds of specialties and their marketplace to show off their work. So get us to help you be successful. So it's time to seize the opportunity in front of you. You've got a great access to great technology. I know your organizations are dealing with challenges. They want your help and need your help. They just don't know it. I'll leave you with one thought, and that is there's a difference between having a job and building a career. Think about which one you want to do. And also think about when you're gone from this job, how are you be remembered? How will people talk about you? It's about building a legacy and showing your value. So I'd love to connect with users. You can reach out via that email on GeoNet, Twitter, or LinkedIn. And I know that was really fast, but I'll send you guys the slides, and I'm happy to answer any questions real quickly.
If you want to ask a question verbally, just raise your hand.
Are we good?
I don't see any questions.
Okay. Then I'm going to be mindful of the people that need to go after me, and I will stop sharing. Thanks very much for the opportunity.
Thank you, Adam. Okay, Brian, you are up next.
Okay, 1 second. Wasn't quite moved into my space yet. Okay. Can you see me and hear me all right?
Yes.
And can you see my screen now?
We can just see a small version, not the slides themselves. The window. There we go. Now we can see it.
Okay, cool. Well, I guess I've got a little bit extra time, but I probably shouldn't take us all the way to 11:30. My name is Brian Shaw, and I'm the Rocky Mountain Regional Geodetic Advisor. That I work for NOAA's National Geodetic Survey, and we're in charge of providing the geospatial infrastructure to the U.S. For positioning. And so I'm going to talk a little bit about that, as well as how we're modernizing the National Spatial Reference System. First, I often throw this at the end, but I wanted to kind of, since I often go very long, I wanted to make sure I provide this information first. We have tons of resources for users to be informed about the changes coming to the National Spatial Reference System. We have training center that normally when things are normal, we have a lot of in-person courses that we train at our training center in Corbin, Virginia, which is near Fredericksburg. We also have tons of educational videos about what datums are, the difference between the feet, the state plan, the survey foot and the international foot, as well as information about the datum changes that are coming. We do a webinar series. We have a webinar every month that informs the public on different things. So you can sign up for emails on that. We also had held several geospatial summits, and in the last one last year, we recorded a lot of the sessions via webinar, and so those are all accessible to view, where last year's Geospatial Summit really had a lot more information about the modernization coming, as well as this presentation and any presentations that NGS employees give are put into the presentation library. So these are public, publicly available. You can download them, you can reuse the slides. Because we're federal government, all of our information is public domain. With that, you can see here on the left, the 14 regional advisors we have that cover all of the U.S. states and territories. My region is Colorado, Wyoming, and Montana. A very important part of the advisor program is having coordinators in each of these states. So we're federal advisors for geodetic needs, but having these state coordinators really helps us to understand the state needs. It has people that are tied into the states that can inform us when legislation's being worked on, or if the state's planning on doing a LiDAR survey and needs some help. These coordinators really help to feed information from the state up, because it's very hard to be nested fully into the state. So having this coordination is very important to our jobs. So I'll talk a little bit about the history of NOAA and the National Geodetic Survey. In 1807, Thomas Jefferson created the Survey of the Coast, which was very important because back then all of our commerce was done through shipping, generally overseas. So all of the agriculture and everything we were generating here in the U.S., in the colonies and states once we became a nation, was done through shipping commerce. And getting these ships into port safely was very important, but we needed to know about the offshore obstructions, so the bathymetry and the seamounts and the different obstructions that cause shipwrecks. But to understand the bathymetric things, you really needed to know where the land was and be able to tie that land to these bathymetric features, which was why the Survey of the Coast was created, often to create these nautical charts to assure safe shipping, which is a fundamental reason of why we're in the Department of Commerce. And so he had hired Ferdinand Hasler to be the first superintendent of the Survey of the Coast. He was a Swiss surveyor that brought a extensive knowledge, helped us to get a whole bunch of instrumentation and go about performing surveys and densifying this, what today we call the National Spatial Reference System. For many, many years, we were called the U.S. Coast and Geodetic Survey. And then in 1970, we were grouped with the Weather Service, the Fisheries Service, kind of creating a massive scientific agency called the National Oceanic and Atmospheric Administration. And so what is our mission today? Our mission is to define, maintain, and provide access to the National Spatial Reference System to meet our nation's economic, social, and environmental needs. So what this means is providing accurate positioning, allowing roads to be built properly, bridges to be constructed, floodplains to be mapped, and emergency evacuation routes to be planned where it's not going to be flooded. So all of those things rely on accurate positioning, which is the main purpose of the National Spatial Reference System. And so the importance of geodesy, on the left here, you can see Hasler's first fieldwork was done in New York Harbor. And so back then, the way surveying was done is you would have these geodetic monuments and you would turn angles with a theodolite to determine horizontal positions. And so here you can see a bunch of the vectors and the stations on the map. Then moving forward, 150 years, you can see the map that we put out with USGS in 1969, and having USGS kind of topography beneath the geodetic control network. And you can see again, we were still doing triangulation in 1969 all the way up into the 80s, until on the right you can see the network today of GPS vectors. And so nowadays we do almost all surveying with GPS. So you can see the vast amount of network configuration of this GPS network. And then our sister office, the Office of Coastal Survey, is still putting out these nautical charts. And so using our accurate geodetic positioning, as well as they're going out and doing bathymetric surveys to accurately determine what's underneath the water for safe shipping. So these are very important because I forget how many billions or trillions of dollars of our economy is coming through the port still, and then being put onto trains and then being put onto trucks. And so part of our job at NGS is to build models to simplify the world, because the world is infinitely complex. Maybe someday, because our technologies continue to improve and we continue to be able to collect more data, we will have an exact second a digital representation of the world. But moving through the past and up to today, we really needed to make these models that help to simplify this infinite complexity. And so, from creating a sphere and generalizing the Earth as the sphere, to then understanding that it's an ellipsoid, an oblate ellipsoid. So having an ellipsoid model to help represent it, to on the right here, you can see the geoid, which is essentially the representation of global mean sea level. And so having these models really helps us to provide a means for geospatial infrastructure, and so without being infinitely complex. Moving to the future, gravity, as it's always been, is fundamental. So from back when Aristotle was determining the force of gravity by dropping objects off of the Leaning Tower of Pisa, to various other scientists determining new things about gravity and it's in our relationships to gravity and how it keeps us on the ground and how the centripetal force of the Earth spinning affects things, and to Einstein's theory of general relativity, which was just proven scientifically. I think it was about 5 years ago where they measured it, but he had that theory over 100 years ago. What we're doing today is we're going out and collecting aerial gravity surveys for all of the US states and territories. And so here you can see the progress we've made. The first survey we did was out of Montgomery, Alabama in 2008. I had the pleasure of flying on that first survey, where we were flying at multiple elevations to determine, and multiple speeds, to try to determine what was the ideal line spacing of the gravity with the flight plans, as well as the optimal altitude to fly. And so since that time, we've been going across the whole US, and you can see all of the green blocks are all of the completed data blocks. The orange blocks are where we're still collecting data, although many of our surveys have been put on hold. We're working on figuring out a way to safely do that nowadays, but that, if you've heard, the NSRS modernization that we'd initially planned to roll out in 2022 has been delayed. And this is one of the fundamental reasons why, is we really need this gravity data to complete our models and to create the most accurate positioning available. And so once things are running up again, we'll complete all of these blocks. We'll go out to finish up Samoa, Hawaii, and get out to the Aleutians and Guam and the Northern Marianas. And so datums and reference frames are fundamental to this positioning. And so I've worked at NGS for over 18 years, and I guess I forgot to introduce myself on various things. And so, I'd started out as an IT specialist, and GIS was my main expertise. Then I got moved over to our Geodetic Services division to help to create web pages and geospatial applications for our users. And I've moved up to the regional advisor position. And so I've been in our IT department. I've been doing GIS the entire time, but really grasping this concept of datums and reference frames took many, many years for me to really understand and get a model in my head. And recently it kind of clicked that, a datum is just a reference surface or a reference point for which all of the rest of your data is referenced to. And so the way I thought of it is, when I was a kid growing up, we would stand against the wall and your parents would measure your height, over the years and see how you were growing. And basically that reference surface, let's say it was carpet next to the wall. And so let's say if after 10 years, my parents decided to put in hardwood floors and replace that carpet. Well, because they're changing that reference surface, those heights that were on the wall will no longer be applicable unless you know the exact height difference between when it was carpet and when it became hardwood floors. So what we're essentially doing with this NSRS modernization is we're just changing that reference surface. Heights aren't going to shrink or raise just because we're changing that reference surface. We're just changing that surface for which all of the heights are referenced to. And so I know heights in Colorado and in Wyoming and in Montana are going to be going down a little bit, but it's not, the heights aren't actually shrinking. It's just that reference surface is changing. And so why are we modernizing the NSRS? Well, the Datums NAD83 and NAVD88 were created on old technology. These were using surveying methods that we'd used for hundreds of years, or not hundreds, but over 100 years. And so also back when NAD83 was created with the ellipsoid model, GPS was just starting out, and they were using Doppler measurements to kind of determine where the Earth's center was. But nowadays we've got it mapped to a much more accurate level, and we understand that the center to the NAD83 ellipsoid is not truly geocentric, and that brings in some inaccuracies especially when you're going out working with global data. And so it's off by 2.2 meters. So NAVD88 relies on marks in the ground. So the way you would currently get an NAVD88 height is, a very accurate one would be to go out and perform geodetic leveling from a mark in the ground that has an NAVD88 height already. And generally you have to actually tie into multiple marks. And what we know today is these marks are not stable. They're not staying at the same place in time. Some of them are moving due to various tectonic factors or groundwater withdrawal or various things. And so even though we're currently publishing heights on marks that haven't been visited since sometimes the 30s and 40s, other times the 60s or 70s, we're still publishing heights of those heights that were determined back then. And so we understand this is not a good model for, especially in today's world of accurate positioning. And so today we need to provide a better geospatial infrastructure, allowing you to get a more accurate position than what you can today. And so some of the benefits of modernizing the National Spatial Reference System are these fast, accurate, and consistent elevations everywhere through GNSS surveys. And so with that gravity data we're collecting, we'll allow people to get 1 to 2 centimeter level accuracy positionings from GPS. And so this will help many things, from improving public safety, like the floodplain maps, the emergency route planning, all of the digital elevation models that are referenced to ground control points with elevations, as well as accurate positioning for the future of what we're building towards today with autonomous vehicles, with building infrastructure models and smart cities. To have all of these things work properly, you really need to have this geospatial infrastructure allowing everything to know where it is in a more accurate way. And so another reason to go for moving forward is this paradigm shift in data and technology. These datums were built on old technology, and they were really built for that old technology and the different accuracy needs of those technologies. And since we put these out, unfortunately these came out, the time when GPS was really just beginning to become available to the public. And so NAD83 was put out in 1986. The first GPS satellite went up in 1978, and NAVD88 came out in 91, and we were already starting to do GPS surveys just a couple years after that. And so these datums were built off of over 160 years of data for NAD83 and over 130 years of geodetic leveling for NAVD88. There's many different technologies that went into these, but again, the technology was just beginning to change, and in the last 30, 40 years of technology, things have just exponentially increased. And so back then, the mainframes that were running the processing for building these datums probably took up as much space as my house. So today, I think my phone's probably got more processing and storage than the mainframes that took up a whole house. And so wanted to show a little video of kind of the history. These datums were not a small effort. And so, so if you look at these maps here, on the left, you see what's called a Bilby tower. On the right, you see this map where all of these triangulation networks here. Every point where those lines come together, someone probably built a Bilby tower or there was a mountain. This was a massive surveying effort to cover the entire nation, to get accurate positioning, to create, the NAT 83 as well as the datums before it. And so this was a huge effort to build these towers and go across the nation for the horizontal. The vertical is the same. On the left, you see a man with a rod there. All of these red lines here, people had to walk every kilometer where there's a red line. And they were doing measurements between two rods to get very accurate elevation differences. So this entire network that we created through hundreds of years, took a vast amount of effort. In the 1930s, because of the Great Depression, we were actually able to, through the Works Progress Act, hire a bunch of unemployed engineers to help us densify that network. And that's when a tremendous amount of that leveling was done in the 1930s and 40s. And so, a lot of good work went into creating those datums, and I don't want to, de-emphasize how important and how much work went into them. But today we understand things are different with this paradigm shift in data technology that really GPS and GNSS, which includes all of the other national constellations, have allowed us to do. Also VLBI, which, uses very accurate stations to determine positions to, millimeters based off of looking at quasars and stuff, to SLR, Doris, and the geopotential, which is essentially gravity. Understanding this geopotential, we've got satellites up in orbit now giving us satellite gravity models. We're going out and collecting airborne gravity, and we've got much more accurate surface gravity. And so by tying these three gravity references together, we're really getting a much more accurate representation of where water will flow and what, true sea level heights are. And so this allows for the digital elevation models to be created and much more accurate. And so we're really getting into a point today of technology needing this more accurate infrastructure, which is, with working with cloud servers and satellites and new surveying technologies that give us a super accurate position in mere seconds. So this is the real reason of the need to modernize the National Spatial Reference System. Some of the other reasons are international, national, and local consistency. Making sure that counties are collecting in the same system as the state, which is collecting in the same system as the federal government, and easily relatable to international efforts. So, Puerto Rico working with some of the other Caribbean nations and all working in the same system when hurricanes or other national, earthquakes and other major disasters are happening. If everyone's sharing a bunch of data, but everyone's using different datums, it's really going to cause a lot of confusion. If they don't get everything into the same reference system, they'll be forming analysis, making incorrect conclusions or analysis. And so having this reference system that everyone's using will only help to make for more accurate and better analysis. And as well as, transforming to the ITRF, which is the international system. And so the modernized NSRS is going to be built on top of ITRF, which will make it much more easier for us to collaborate with friends and neighbors. And so, what is accuracy versus precision? And so a good friend of mine, Michael Dennis, had told this, and I've really liked it. Accuracy is telling the truth, telling exactly where something is. And that's what the future National Spatial Reference System is going to be. Precision is telling the same story over and over again. Getting repeated results. Even if you're getting the wrong thing, you can still be precise if you're continuing to get that wrong thing over and over again. And that's often the current NSRS. NAVD88 is a very precise datum. It allows you to get consistent heights from current benchmarks. But those heights aren't always correct, because nowadays we understand there was a systematic tilt in the leveling done, because from seeing that map of all of the red leveling that was done across the entire nation, there was a systematic bias continuing to build up, whereas right now in Seattle, I think true sea level is about 1.5 meters off of what it actually is if you're looking at the height on a benchmark. And so we need to provide that more accurate system. Moving to the future for you, if you only need a mapping quality position, then maybe you don't need to worry so much about making sure that you have NAD83 or WGS84, which I know a whole lot of software packages and GPS receivers are telling people they're getting WGS84. That's a whole another presentation in itself, but you should really be using the National Spatial Reference System, making sure you're collecting data in NAD83. If you're not, and you're fine with 3 meters of uncertainty, then you can assume it's WGS84. But if you want to be accurate for such as geodetic and survey accuracy, you need to make sure you know what datum you're using, when you're collecting that data, how you're processing it. And so I'll mention it later and I'll mention it now. Metadata about what datums and reference frames your data is in is going to be essential, particularly to moving to the future National Spatial Reference System. And so what can you expect? Here in Colorado, you can see on the left, it's roughly about 1.2 meters to about 1.4 meters of horizontal change. Up into Montana, it gets up to about 1.5. So again, the land isn't moving that way. Just the reference system, which we're referencing it to, is shifting horizontally, as well as vertically. Colorado is going to be going through a shift of roughly a 0.5 meter to 0.75 meters. And so up into Wyoming and Montana, you're going more up to, I think Wyoming is just under 1 meter. Up into Montana, it's going up to about 1.3 meters. And so again, these heights aren't shrinking that much. It's just that surface is being changed. The surface with which we determine mean sea level is adjusting based off of all of this gravity data we're getting. And so we've got much more data to create a much more accurate model today than we did for NAVD88. The future reference frames, we're creating reference frames for each of the plates. We have states and territories on 4 plates: the Caribbean, the North American, the Pacific, and the Mariana. So we're creating reference frames for each of those because each of those plates is moving in a different way. For instance, this shows you kind of the movement of the North American plate, the Pacific plate, and the Caribbean plate. You can see the North American plate is kind of doing this slight rotation, whereas the Pacific plate is going kind of straight up northwest, and the Caribbean plate is kind of going up to the northeast. And so each of these plates is doing something different, which is why we've created these reference frames working with each of the individual plates, helping us to model the velocities and where things are moving. And so vertical motion is much more challenging. It's not a consistent shifting like you saw in the horizontal there. There's subsidence due to ground fluid withdrawal and sedimentation, where people are extracting oil or water and causing the ground to sink. There's glacial isostatic adjustment, where back during the Ice Age, the ground was super compressed down, and now with all of the glaciers melted, the land is rebounding, as well as just instantaneous geophysical phenomena like earthquakes, caldera eruptions, and then kind of a seasonal earth tide. And so vertical motion, I've got a couple maps here. On the left, you can see the GIA causing the uplift of around the Hudson Bay. It's not a small amount. It's at about 10 to 12 millimeters a year right near Hudson Bay, which, if your data is 10 years old, that's up to about a meter, or I forget, but centimeters of change. So, and then on the middle here, you have a USGS study that shows the San Joaquin Valley subsided, up to 2 feet in 16 months. 2 feet is not a small amount. And looking at the right, you can see how much that subsidence added up over 50 years, 8.5 meters over 50 years. And we're using far more water nowadays than we were using back in the 50s and 60s. So having a system to be able to track these changes is very important. Instantaneous changes like the China Lake, California earthquake or the Puerto Rico earthquake caused 6 to 10 feet horizontally shifting in the China Lake example, and in the Puerto Rico example, 16 centimeters of vertical change instantaneously. And there's still going to be some changes going on even after the earthquake happened as things settle. One of the ways we're helping to track this data and understanding how things are changing is through our GPS on benchmarks effort. Currently, we're doing a GPS on benchmarks for the transformation tool that will help us to create the best transformation model moving from NAVD88 to the new geopotential Datum. And we've got this web map on the left, and we've got a dashboard tracking the efforts on the right. These efforts also fed into the Geoid 18 that we just recently put out, which was the last hybrid geoid model that allows you to get NAVD88 heights with GPS. Moving forward to the NAP-GD 2022, it's the geopotential Datum, but it's not just about heights. This is a geopotential model that understands how gravity is changing and moving. The deflection of the vertical helps for positioning. Gravity and the geoid models really help us to understand this relationship. And so this will be one basically vertical datum for all of the states and territories. We've also got the state plane coordinate system that we're updating. And so here's a map of the state plane coordinates. Again, this presentation will be available for download, and I know I'm getting close to my time, so I want to have time for questions. But in Colorado, on the left, you can see the statewide zone. That's the preliminary zone for the new system. And on the right, you can see the UTM reference for the current, if there was a current statewide zone and the inaccuracies of it. So comparing this, we will be providing much better state plane coordinate systems for the future. And many states, including Colorado and Wyoming, are planning to have LDPs included in this. And there's Wyoming. So how you can prepare, metadata is going to be essential. You need to know what your data was collected in, how it was processed, how it was transformed, and having all of this information tracked. So if something incorrect was done, you can back that out. As well as if you're collecting heights with GPS, you need to make sure you know what geoid model was used for that height. Because if say it was used 12B and you realize 18 is much more accurate in your place, being able to back that out and put it into Geoid 18 would be much more easy to do if you know for sure that you use Geoid 12B and not say Geoid 09. Making sure that when you're putting out mapping contracts, making sure what datums, they're providing the data in, how it was collected and processed. Preserving your original observations, so if maybe there was a blunder, you can go back and reprocess it. Some of the recent publications that we've put out about this modernized spatial reference system are these blueprint documents. We're currently updating these as many of them had to be determined, which we've determined. And so we've been updating these. These should be out by the end of the year, as well as a state plane coordinate system, history, policy, and future directions document. And with that, I think I was right around 30 minutes. But if there's questions.
If you have questions, you can type them into the question and answer box or raise your hand.
And for anyone that's interested, this map is a deflection of the vertical. So the mass of the geology underneath causes the deflection of the vertical to change. So while it might look like a topographic map, if you know anything about Iowa and Minnesota, there's not actually any mountain or anything here. This is what's called the Mid-Continental Rift, where however many years ago the North American plates started to split and magma came up, which created this dense gravity feature here, and then it just stopped. But I don't think I see any questions.
No questions so far. Okay, last chance for any questions for any of our panelists at this point. Otherwise, we're going to finish up. And then okay, no questions. Thank you, everyone, for attending. Thank you to our presenters.
Thank you, Darcy, for setting this up. And thanks, everyone, for tuning in.